Yo, this is your boy from ETABS tutorial, welcoming you to a new video on ETABS modeling analysis. Today we'll be learning about beginner version of modeling analysis of simple three-story building in ETABS. Okay, so we'll be modeling this building. The plan of the building is here. Ground floor, first floor, and second floor will be the same. As a prerequisite of this video, I would like you to have a brief knowledge of these four things before you begin the video. IS 1893 part 1 2002 and IS 456 2000, a basic knowledge on MS Excel, a few formulas here and there, because we'll be using MS Excel extensively for our calculations. RCC course book, preferably Ekizen or Menon and Pillai, whichever is handy is better, or any RCC course book for your reference. Okay, to begin with, this is the screen you will encounter while opening a freshly installed ETABS. So firstly, you have to go to File and New Model to create a new model. Okay, I would like to tell you this. Okay, I would like to tell you that we'll be dividing our video in modeling and analysis in two parts. The first part will be modeling. The second part will be the analysis. Okay, the first option here will be used when you have saved a default user setting. Okay, since we are doing a brand new modeling, so we'll be using use built-in setting with the third option over here. Set the display units to metric SI, since we'll be using SI units in our design. Still, the seal section database to Indian section database. This is not required in RCC building analysis, but still also we'll be putting in the steel section database to Indian code. Make sure you set all the options, all the section databases and codes to Indian code. So concrete design section will be using IS 456 2000. Set to OK, and we are here with the new model quick template. Okay, so select grid only in structural elements and use custom grid spacing and custom story data. Okay, then go to edit grid data. So we have here 1 2 3. Make sure that every column is in the intersection of the grid. First of all, display grid data as spacing, because we have spacing in the plan. Okay, so x direction grid data. So for x direction grid data, the spacing between the grid A and B is 10 feet 9 inches, and between from B and C is 11 feet 5 inches. So we're putting here 10 feet 9 inches, 11 feet 5 inches. So we don't need the grid D, so select the grid D and press on delete. And now inserting the values of grid Y. Select on this grid over here. Okay, so the first spacing is 13 feet 9 inches, then 13 feet 10 inches, and 5 feet 1 inches. 13 feet. So you can add or remove additional grids from here. After you have inserted the values of grid spacing data, okay. So now we need to input the story data. So you press on edit story data. The given problem, the story height for the given problem building is 9 feet 5 inches, and it's 3-story with a stair cover over here. So the foot 3-story including stair cover, 3-story including stair cover. Okay, so 3-story including stair cover. So we don't need this 4-story over here. So So what I'll do is right click over here, delete story, delete existing structure story. So first story will be 9 feet 5 inches, second story 9 feet 5 inches, sorry 5 inches, third story will be okay. uh, Talking about the master story, the master story is such a story that which the settings of the story can be copied. For example, if you set story 1 as a master story and similar to story 1, we can copy the same load patterns and structural elements. This will be very handy modeling when drawing the model in ETABS. Okay, so this will be very handy when drawing the models in ETABS. Press on OK and press OK over here. So after pressing OK, we'll be displayed with the 3D vision and a plan story of this view. So if we this will display the 3D model and this will be the plan model. I personally would like to work only in one window, so I will close this one. Now we have to define the elements. Okay, the elements beam, we have to define the beams, the columns and the slabs. Okay, their properties. So firstly go to define material properties. First we have to define new material, save the region as India since we are using IS codes. Material type, first we'll define the concrete. Okay, standard is Indian standard. So grade, so we'll define M20 concrete grade M20 for beams. Okay, so material type concrete, isotropic, input the density, rest you don't have to change, click on OK. To define the rebar material, click on add new material, select rebar from material types. So we are using HYSD 500 generally. So okay, steel grade, steel rebar grade, sorry, rebar grade FE 500, high strength deformed bar of grade 500. Press on OK. These are the by default properties, you don't have to change these. Press on OK. And so here are your two materials which we will be working on. Click on OK. So to define the frame properties of beams and columns, go and define section properties and frame sections. Here we'll be using the following beam and column sizes. For beam size we'll be using 9 inches by 14 inches, 9 inches by 16 inches. If this fails, we'll be using this one. For columns, we'll be using square columns of 12 by 12, 14 by 14 and then 16 by 16. So go on to add new property. So this is a concrete section, so we'll be selecting concrete. Property name will be beam by 14. Okay, so the material will be M20. Section will be concrete rectangular. So here will be the depth will be 14 inches, whereas the width will be 9 inches. Then click on modify story bar. For beams, select only M3 beam design only, and the longitudinal bar should be of HYSD 500. Select HYSD 500 on both of these. Cover to longitudinal rebar group centroid, the cover should be minimum cover to beam should be 25 mm clear cover. So add 10 mm the centroid of the rebar group, so that would be 35 and 35 over here. This area leave as it is, click on OK. So we are done. Click section properties. Okay, modifiers all one here, leave it, leave as it is, click on OK. Now the second thing we are going to define is our column. Add new property, select column from here, concrete from here, and then name it C 12 by 12. And you also want to name the composition of the rebar in it, since we'll be using this type of column with 4 corner bars and 4 middle bars. You want a column symmetry in it, such as okay, the symmetry in the x-axis and the symmetry in the y-axis also. Okay, so we'll name it as 4 12 mm die corner bars plus 4 12 mm die corner middle bars. The material will be M20. Okay, so here depth is 12 inches by 12 inches, and then go to modify SOAP modifiers. So all values should be 1. Click on OK. Go to modify show rebar. Okay, so we'll be doing column design. The longitudinal bars should be a property HOSD 500 of the confinement bars also. So the column configuration should be rectangular, confinement bars should be ties. The reinforcement is to be designed, so click on reinforcement to be designed. Clear cover for confinement bars is 40 mm, which is okay. Number of longitudinal bars along 3 directional face is 3. Okay, the 3 directional face is over here. The 3 directional face is we want to have 1, 2 and 3 bars. So the number of longitudinal bar along 2 directional face, the 2 directional face we also want to have, since our column configuration is 1 2 3 on this side and 1 2 3 on this side, so we want to have this also 3. Longitudinal bar of size 12 mm diameter, since we have specified it as 12 mm diameter bars. Okay, confinement bar and size 8 mm. This is general use of practice. If in a region it uses 10 mm, you can put 10 mm. If in your region the general use is 8 mm bars, so you can put 8 mm. Okay, so rest you don't have to change anything. Click on OK. So now you have the right column composition according to rebar composition according to our design specification. Okay, so that's good. Now show section properties. Okay, the section properties are good, so click on OK and click on OK. Now we have defined our beams and our column. It's time to define slabs. Go to define section properties, go to define and section properties, slab sections. Okay, so we want to add a new property. We want to, like, let us say slab 125 mm. The property is M20. Slab, okay, the floor slab is a thin cell. The floor slab is a thin cell, so you want to define it as model is a thin cell, cell thin. Property type, it's a slab, and the thickness is 125 mm. Click on OK. Okay, so this will be our slab. Click on OK. Now we will draw the model using the sections that we have defined. Go to elevation, select A. So this is along the grid A. Okay, along the grid A, 1 2 3 4. So this is along the grid A. Go to draw beam column. Okay, so type line is frame. The properties that we have defined is column 12 by 12. Okay, column 12 by 12. So similar stories, if you make similar stories, it will be applied to both the stories. Since we have defined this as a master story, whatever models, whatever section elements you will draw, it will be copied to this upper story. To draw beams, make sure that you go from left to right while drawing beams, not the haphazard manner. Make sure you follow a consistent pattern so that you can align the local axis of the beam with the global axis of this entire structure. So make sure you follow a pattern going from left to right and down to up. You can also check your structure in 3D. The terrace floor consists of only this part, the stair cover. So we'll be making only this part in the third story. Only model only the structural elements, beams, columns, and slabs. Okay, we don't have to model non-structural elements such as walls, you know, parapet walls, partition walls. We don't have to manage that. Replicate these four to the third story. Now we have the model as the first two floors and the terrace floor, the first two floors and the terrace floor. So now we'll be drawing the slab. Okay, there are different ways of drawing slabs. The first and basic way is through this draw floor wall pattern. Make sure you have enabled similar stories. So this will enable, since you are in story 1, whenever you draw a floor in your master story, the same will be applied to your similar stories also. Since our story 2 is similar story and story 1 is a master story, whatever we have drawn in master story will be applied to the similar stories. Okay, this is easier way of drawing. Also, you can draw quick draw. You can use quick draw tool to draw. Okay, this is a very easy way of drawing in a perfectly rectangular grids. This portion has a staircase and a small room attached to it, preferably a toilet or a bathroom, washroom. So we'll provide a secondary beam over here to support this slab. Okay, so as a designer you can add secondary beam wherever required in the structure. So to add a secondary beam, let's see the dimension of this portion, 3 feet 9 inches. The easy way of doing this is selecting this beam, replicate it to 3 feet 9 inches along x direction, positive x direction along this side. Click on apply. So this is applied to upper story also. So this portion is a staircase portion. We will leave this portion void because we will not be modeling staircase in ETABS. If you want to model, you can use one-way slabs and model this portion individually, this portion and this portion, using reference planes. And you have to add reference planes to model this slab. So we are not going through that long process, and the shortcut method is calculating the load, dead load, live load of this portion and distributing to these two beams, these two supporting beams. That is a fast way of analyzing structures in ETABS. So we'll not be modeling staircases, but we will be designing them manually and distribute the load in this and this beam. Okay, in the end beams. So we will not be modeling staircase over here. We will design the staircase manually and apply the load over here and here. The dead load and live load will distribute it over here, both sides. Let us look at the 3D model. So our model is almost complete. You can look at the 3D view of the model also, or you can check in the rendered view section also, just to get a 3D image of a model. Okay, so close this and extrude views. Okay, so Now we'll be adding loads in our structures. Okay, first we have to define the types of load. So go to define load pattern. Okay, so first you want to define self weight of structure. This is a dead load. Self weight multiplier should be 1 in self weight. Add new load. You can remove these two load because we will define our own loads. So the next load is live load. This is type live. Self weight multiplier is 0. Add new load. The next load is dead load from different objects above in our building, such as table, decks and chairs. Dead load. These two are different. Make a note that self weight and dead load is different. The type for here is superimposed dead load. Okay, so add new load. Another type of load is floor finish. This is also superimposed dead load, so add new load. The next load will be earthquake load in x direction. Type seismic. Autolateral load is IS 2002. Click on add new load, then click on modify load. Okay, so this is in x direction, so remove this. Seismic zone factor 0.36 according to your zone, which zone is light. Soil type 1, 2 or 3. Important factor 1. Okay, top story, base story. So in time period, you can select approximate. To use approximate time period approximation, program calculate to let the program ETABS calculate itself, and you can use user defined if you want to define the own time period. The most accurate is approximate, so the coefficient is 0.03 according to IS code, so this coefficient you want to put it for RC flame buildings. Okay, so time period approximation, response reduction factor is 5 according to the code. These all values you have to put it according to the code. Okay, so then click on OK. Other load is EQY, seismic. Add new load and click on modify lateral load. This one should be in Y direction. Approximate 0.075. Click on OK. So these are the load. Since we'll be adding staircase load to the beams, you can also add staircase dead and staircase live load, just to define load patterns, or you can add or subtract the required load patterns over here, the loads that is coming to the building. Click on OK. Now we will be defining load cases. To define load cases, go to define load cases. So since there are too many cases over here, so we're gonna delete all the cases and group the load cases in one. So case 1 is going to be dead load, so linear static. Make sure you choose linear static on here. Self weights load pattern. Next one will be dead load. Another dead load is floor finish, and another dead load is staircase dead. So these all are going to be grouped under dead load. Okay, so another case is live load. So we're going to group all the load patterns in different load cases, so these load cases are grouped together. So live load, here we'll add all the live load, and also the staircase live load. Make sure the scale factor in live load is 0.25 Also for the staircase live load is 0.25. You can ignore staircase live load if you have not defined it in load pattern. Next is EQX. Add EQX. Okay, other case is EQY. Add EQY, click on OK. So these are the 4 load cases that we will be using in our analysis. All the dead loads are grouped in dead, all the live loads are grouped in live load. The earthquake X direction load is grouped in EQX, and earthquake Y direction load is grouped in EQY. Click on OK. So now this third process is to define mass source. Modify show mass source. We already have mass source 1 over here, so we modify show mass source. Uncheck these element self mass and additional self mass, and check on specified load patterns since we already have defined the load patterns. Okay, self load 1 we add with multiplier 1. All the dead loads should have a multiplier as 1. Okay, and live load with multiplier 0.25. As we have inferred from IS code, for imposed load below 3 kN per meter, we can use 0.25. Staircase live load also 0.25. This we have, you can include live load in staircase live load in live load also. I have taken this just to differentiate, to avoid confusion in later parts. So don't add EQX and EQY. Don't add EQX and EQY over here, because lateral mass will be included through these check boxes. Just click OK and click on OK over here. Now that's how you define mass source. After mass sources, it's time to define the load combinations. Okay, so as we have selected IS 1893 2002, ETABS has default design combos, so you can simply add default design combos for concrete frame design. Click on convert to user combinations editable, and then you can click on OK. So there are 14 load combinations. You can edit, you can edit their names if you find it confusing. You can edit this. Let's modify so combo says 1.5 DL. Okay, then you can modify so combo this as 1.5 DL plus LL. Now we have named all the load combinations. Click on OK. You can name the load combinations, or you can leave it as it is, in combo 1, combo 2. But naming them will be easier for reference. Find out the critical load combinations by just looking at the tables later. Okay, so after this, click on OK. After this, click on OK. So now we have defined the load combinations also. Now it's time to add loading to the structure. Before you add loading to a structure, you have to calculate the load by using a simple Excel sheet such as this. You can create your own Excel sheet to calculate load. It's just general math. Okay, the floor finish will be 1.2, will be added to the slabs. The live load will be added to the slabs. The wall load is calculated as follows. 19 kN per meter cube is the unit weight of masonry. We have taken 19 kN per meter cube. Wall thickness is 9 inches. You have to input the wall height, and this is the frame load that will be loaded in the beams of the structure. You can approximately put 11 kN. In places where there are openings such as doors and windows, you don't have to perfectly apply the load, Make sure you consider all the loads in the structure, all the loading patterns, and all the elements for loading. But you don't have to be exactly perfect while applying load. And the parapet load is for terrace parapets. The same is calculated using a wall height, parapet height. You include the parapet height over here. We have included 3 feet 3 inches at the parapet height. The frame load over here. The staircase we have calculate for staircase loading, as we have not modeled staircase in ETABS. Calculate the staircase loading. To apply load, go to assign frame loads distributed. Since wall load is distributed, you have to select this is dead load or wall load. Click over this is uniformly distributed load, so select 7.64 over here. Click on apply and click on OK. I'll select all the slabs. All the slabs wherever the load is applied, and apply assign cell loads uniform. Okay, so you want to assign a live load of 2 kilonewton per meter square, and also a floor finish of 1.2 kilonewton per meter square. That's all. If you have any other loads, you can apply. After completion of application of the load, you have to define a diaphragm. Okay, you have to define a diaphragm. So go to define a diaphragm. So D1, 3 stories, so we have to take 2 diaphragms. D2, apply. Make sure the diaphragm is rigid diaphragm, not semi-rigid. Okay, so we have defined 3 diaphragms for it. Go to story 1. Make sure you have selected only one story over here. Select all the structural components, assign joint diaphragms. Okay, you have to assign joint diaphragms. D1, apply, OK. Go to next story, select all, assign joint diaphragm. D2, apply. Then you can go to the third story. This will connect your structural elements together. Okay, and it will assign ETABS that the whole floor is a one rigid diaphragm. Now assign diaphragm. The next step is the base. So here the base is hinge support. Go to plan, base, select all the points, then go to assign joint restraints. Go to restraints and select this cantilever, or you can all tick on all the check boxes over here. Click on apply. Okay, now go to 3D and look, all your bases are cantilever supports. Now we have defined loads, we have applied loads, we have made the model. So now our modeling step is complete. Now we'll go to analyze portion, the second part of our video, that is analyzing the structure. After you have completed all the steps here, what you have to do is click on analyze and you check model for error. Click on all the check boxes. Okay, select all. You can do select all. Click on OK. So now the ETABS will check your model for possible errors, double assignments or something like that, double assignments, overlapping. The model has been checked, no warning message generated. Now after this we will mesh our slabs. Let's go to analyze and set on automatic mesh setting for floors. Okay, your floors are basically a thin slab, so this setting will help to capture the load from your floors, like the dead loads and live loads that you have entered in the floors. So this mesh size, put it 0.5. This setting is very good, 0.5. Click on OK. Now go to analyze, go to set load cases to run. Make sure you check here, calculate diaphragm centers of rigidity is checked. This is important to calculate the eccentricity of the building after the analysis. Now click on run now. ETABS will run the analysis of the model. the status is revealed over here. So here now your model is analyzed. This is the deformed shape of the model. Okay, so you have to check the, so you can check the displacement in earthquake X and earthquake Y, like this. Make sure your building deflection is within the permissible limits. Also you can see at the story drifts of the buildings. Next you have to check mass participation ratio. Go to display, show tables. Okay, analysis, results, model result, model results, model mass participation ratios. Click on OK. Okay, so within these 12 modes, 90% of your mass of the building should be participated. Yeah. And the next step is, after all the checks of mass participation and displacement, if a model is good to go, you have to design the model. So click on design, concrete frame design, and click on start design check. Now the ETABS will automatically design a model for you. So you can look at the reinforcement value of columns over here, the reinforcement of IJK in beams, 3 sections, and top and bottom reinforcements for the beam. Okay, also you can go to display, sorry, now to design footings, click on this icon over here, display supporting spring reactions. You can go to load combinations and click on the load combination of 1.5 dead load plus live load, because we will be designing footing specifically for this combination only. You can click on tabulated and click on only check on only this FZ, because we want only FZ, MX and MY. FZ, MX and MY, these two are negligible, so we won't be using these other reactions. Click on apply and click on OK. You can get a better view on this plan view. Like, go into base and click on apply. Look, we will be designing footing using these reactions. Also, the point to be noted that these reactions are factored reactions, so they are already multiplied by 1.5. So this is how you design a building in ETABS. Okay, that's all for the video. I hope you enjoyed and learned something new. Give thumbs up if you like the video, and subscribe to the channel, because I'll be posting more ETABS concept videos, and that will be helpful for you. Thank you.